Hello, let's look at one of the challenges from ångstromCTF. It wasn't particularly difficult challenge, but it was quite a nice, let's call it trick that it was using. Or maybe it's like, sometimes it's popular that the binary that we'll get will be corrupted, and that was the case in this example. So the file was corrupted. And based on the challenge name, I guess the idea was that we would need to patch it, but actually it can be solved without patching, and this is what I want to show you how it could be done. So I have the file loaded twice in Ghidra. One is already analyzed by me, so we'll use that later. And for now, let's look how does the file look like when we just open it in Ghidra in the first time. So let me just run it. And so Ghidra asks us if we want to analyze, but we already see this structure here being analyzed a little bit. And if we analyze with default settings, we'll get some functions, but not that many. We'll get some strings. But if we, for example, go to this libc start main, there's like nothing here. If we look at the strings and go to them, we don't see any references. So it looks like there's not much there in this file. Of course, if we scroll here, we can see some stuff, but it's not being analyzed by Ghidra due to corruptions. So what we can do in this case, we can just remove those analysis done by Ghidra for the headers. So I just pressed C and removed all those analysis done, and then we'll start analysis again, and Ghidra will not use this information, at least not that much as before, and it will analyze the whole file. And we can see already there's a bit more information that we found in the strings, and also if we go to the function, there are much more functions than we saw before. And if we go, for example, to the same string, now we see there is a reference where this string is being used, and we can see a function that actually deals with that string, and we can see some XORing, some strings. Okay, hey, you're supposed to get the flag freeze. Here you have the flag, so we can see actual code that might be actually getting the flag. Now we just need to analyze what's actually happening here. So we could analyze it, but I already have it done. So let's just close this one and open the actual file that I was working with. This is the same. The structure here is not shown as I remove it. And if we go to, again, let's start from the strings. We have these strings. Here you have the flag. And if we go to the xref, we can see the function as we saw in the other file. So this call was identified as ptrace with some parameters passed. There is some constants like lead beef being checked that it's equal to this value. Although if we go, it's something else. So also, if we would like to run it, we would have to patch it, because otherwise it won't pass this if. But what we can see, if this constant lead beef is equal to this, then we pass it to this seed value, and then we have a while loop that is being executed 8 times, and we get some random value, and we get something done with this ptrace result and flag values, and we store a result in this result variable. So let's see what this random is, what's going on there. So if we go to random, we actually use this seed value that we saw previously, and we already as identified, we shift the value with some masking, and we use different constants for shifting, so 0, 2, 3, 5, and then we use this seed to generate a value, and we return. So basically this is some kind of pseudo random number generator, with the seed, which is the initial value is lead beef, and then we get this value r, and then we pass it to this function. So where is it being passed? It's being passed here along with the 4 bytes of the flagged XORed with ptrace results. So what does it mean? So ptrace, if you are not debugging, will return 0, and this XOR will not do anything. But if the ptrace that we are betracing this elf file, this will return some non-zero value, and the XOR will modify the flag, so will not get the correct results. So yeah, we pass this random value, part of the flag, to this add function, which is, yeah, when we go inside it, just like adding first argument to the second, so nothing fancy here. But we have to remember this first one is also XORed here, so we might get an incorrect result if we are debugging this and we didn't notice that this is happening here. And as I said, we take 4 bytes at a time, and this random is returning as 4 values, like 4 bytes. So we add 4 bytes to 4 bytes and get 4 bytes of the final result. So how we can get the flag? So actually we have the seed, initial seed. Yeah, so that would be the initial seed. And we also, this flag here, it has the bytes that are being used here. So it's like, yeah, those bytes are being encrypted. So we need those bytes, we need the random values, we add them together, and we get the final or unencrypted bytes of the flag. So we just need to follow what we seen here. So we have a seed. We get the algorithm how to get the numbers. We add them together, and we can print what we are getting as a flag. And this is basically what I did here in this short Python script. So we have a seed. We have this shift function. Get bytes is basically the same as we can see in Ghidra. If we go here, get random, we have those 4 shifts, and there's function here. We have algorithm. Yeah, previously I didn't know that it will be added, so I just name it like that, but in the end it was just add bytes. I have some decode, and the main function is just opening the file. I'm reading those bytes of the flag by just moving to the offset and reading 28 bytes, and then just, yeah, again the loop as we seen in Ghidra. So initial seed is used to get the new seed, which is also the bytes that we used for the adding of the flag. Then we from those bytes we need to convert to an int, because we are doing 4 bytes at a time, and yeah, we need to have them in little endian order. So we use this int from bytes, and also just to limit to 32 bits. Yeah, so we are just not getting outside of the range. And then we can decode those bytes to get a string, and we add to this result, and we move another loop iteration. And yeah, maybe you saw already the flag, but let's just see that it works. If we run the script, we'll get the flag decoded. So ACTF, Patcherman is no more. So yeah, that was, as I said, not very difficult challenge, but we managed to do it without actually patching the binary. We just, undo the initial analysis by Ghidra, run our own, identified where's the algorithm, and yeah, reverse engineer it and write a short Python script to decode the flag. And yeah, that's it. I hope you like this short video, and yeah, if so, then please like and subscribe, and see you in the next video. Bye bye.